numbers. So, may I request everybody to please stand up for our prayer. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Okay, so before you sit down, please pick up pieces of paper under your chair or in front of you, and please arrange your chairs properly. So, let's check your attendance. Begin your count off. Okay, 25. Seems like no one is absent. So, let's move on to our classroom rules, which is abbreviated padayon. We have here P, practice respect. A, act responsibly. D, demonstrate perseverance. A, aim for excellence. Y, yield to honesty. U, uplift one another. And nurture a growth mindset. So, bahalang magkinaon sa basta padayon. So, before we move into our discussion or to our activity, let us first have a review. So, what have we discussed yesterday? Yes? Yes, we discussed about permutation. So, what is permutation? Yes, mister? Okay, that's right. Permutation is the arrangement of things that the order does matter. And we also had discussed the different types of permutation. What are those? Yes? Correct. It is permutation with repetition and without repetition. Let us give ourselves a round of applause. Very good. You really did understand our lesson yesterday. So before we move in to our discussion, of course, let us have our activity. So, have you guys ever played Lotto before? Which I doubt you did because you're still minor and you're not allowed to do so. But have you observed your parents playing Lotto or grandparents? So, I know that you already have the idea on how to play our activity for today. So, our activity for today is entitled Combi Lotto. So, I will be giving you sets of numbers, 10 numbers. I will be handing it to you after the instruction. You are going to choose 5 numbers. Then, whoever matches 5 numbers, his or her 5 numbers, to the draw that I will be doing, will win the first prize. And for those who matches 4 numbers, will win the second prize. And for the third, or matches 3 numbers, will win the third prize. And in any occasion that one had tied in a specific prize, both will equally divide the prize. Are you guys excited? Okay, so please hand in. Okay, are you guys all ready? Okay, again, you just need to match numbers. It does not need that it is in order. Just match numbers, okay? Okay, so we already have a winner, Mr. for the first, and Miss for the second, and third from Mr. Okay, I will be giving you your prize later on. So, based on our activity, what do you think would be our topic, or what do you think are the concepts related to our topics? Combining, correct. Does not need any order, correct. Numbers, correct. So, your um your opinions or your suggestions are all related and are all correct and related to our topic. So our topic for today is combinations. So combinations is somewhat linked to permutations. So this is our learning objectives for this morning. So we have here define, at the end of the lesson, the students are expected to define a combination of total number of objects taken from number of items chosen at a time, differentiate permutation from combination, and appreciate the importance of permutation and combination in real life scenarios. So, let's move on. Combination. A combination of n objects taken from R at a time is a selection of R objects from the n without considering the order. So here, we are going to combine things such as um, the fruit bowl here. If we have a fruit salad, we really don't need to do it in order, right? The components of a fruit salad. Just like here in combination, we combine things without considering the order. So, N stands for the total number of objects taken at the number of item chosen at a time. So, this is the formula for combination. We have here NCR is equal to n factorial over r factorial quantity n minus r factorial, where n is the number of total objects, r is the number of objects chosen at a time, and yes. So, have you observed that the formula in combination and permutation and is somewhat alike? The difference is the r factorial here, right? Yes. So let's move on. So we have here the types of combinations. Just like permutation, combination has its two types as well. You have here the combinations without repetition and combinations with repetition. So two combinations without repetition. So combinations without repetition, if the ordering is not relevant, the repetition is not allowed, and there are n objects to choose from, then there are different combinations of our object possible. We have here the formula NCR is equal to n factorial over r factorial quantity of n minus r factorial. So, in order for you to understand, let us first list. So if we are given A, B, C, D, and we need to take two letters at a time. So our N would be 4. And our R is 2. Okay, so let us start. There, we can't repeat letters. So our data or our combinations are A, B, AC, AD, BC, BD, and CD. To verify if our listing is correct, let us use our formula. So we have here NCR is equal to n factorial over r factorial n minus r factorial. We have here 4 times 2 times 3 times 1 over r factorial, which is 2 times 1, and n minus r is also 2, right? N minus r, 4 minus 2, right? So what's the answer? 2 factorial. So 2 times 1 as well. So we will cancel. We are left with 12 and 2. So 12 divided by 2, 6. Is our answer the same from our listing? Correct. So there will be 6 two-paired letters in a four-letter combination. Okay, to further explain what is combination without repetition, let us have our example. So, we have here from 8 different colors. How many combinations of 3 colors can you make? So, given that problem, what do you think is our N? 8. Okay. N is equal to 8. How about our R? 3. 3. So what are we going to do next? Okay, so we're going to write our formula. So we have the formula NCR is equal to N factorial over R factorial N minus R factorial. So you have your NCR. So what's our N? 8. What's our R? 3. And I'm so sorry for that. And we have here 8 minus 3 factorial. So let's move on. So we have here 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. 8 minus 3? 5. So 5 times 4 times 3 times 2 times 1. So we're going to cancel here since they are the same. So we are left with 8 times 7 times 6, which is parallel repetition. So we have here 8 times 7 times 6 is 336 over 6. So what would be our answer? 112. I know, I'm sorry. Is 56. Do you have questions or clarifications towards this? So out of 8 colors, if we combine 3, we will be having 56 colors, 56 color combination. Do you have questions? Not so far. So let us move on to the second example. We have here a team of 4 players is to be formed from 9 candidates. How many ways can this be done? So we have here our N is 9 and we have our R is 4. So NCR is equal to 9 factorial over 4 factorial 9 minus 4 factorial. So from here, without using yet your calculator, I will give you 1 minute and 30 seconds to answer. Okay, time's up. So what would be our combination? What would be the answer? 1, 2, 6. Are you sure? Okay, so let's solve. Okay, you are all right. So, now, since I told you that you can bring scientific calculators if you have at home, so I will teach you on how to use your calculator as a tool in solving combinations given bigger problems. So we have here, remember NCR. So in this case, our N is 9. And you can see here at the upper right corner of your calculator, NCR, under alpha, you press that CR. Then our R is 4. So put equal. The answer is 126. Is it the same from our solved problem here in the board? Yes, it is the same. That is a trick for you guys if you're dealing with bigger numbers. But as for now, since we are just dealing with small numbers, it is okay for us not to use the calculator. It's just a perk that you know how to solve this in your calculator. So, with before we move on to our discussion or to the next topic, to the next type of combination, do you guys have any clarifications or violent reaction towards our discussion in combinations without repetition? Yes? Yes. Here in combinations without repetition, we are using the formula of combinations. Do you have any clarifications? None. Okay, so now let us move on to combinations with repetition. So the difference in this is that here in combinations with repetition, you can repeat. So we have here, if the ordering is not relevant, the repetitions are allowed and there are n objects to choose from. Then there are different combinations of our objects possible. So we have here NCR is equal to quantity of r plus n minus 1 over r factorial times the quantity of n minus 1 factorial. So in this instance, if we are still given A, B, C, D, and we need to know how many ways or how many combinations we can make if we get 2, right? So if we are listing with repetition, we can add A, 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 B, B, C, A, C, A, D, B, 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 C, B, D, C, 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 D, and D, D. How many combinations are there? So we have 10. A, B, A, C, A, D, B, 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 C, B, D, C, 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 D, and D, D. So, teacher, why can't we do A, B, B, C, I mean, C, A, and D, A? So, it is because BA and AB are just the same thing because you're just, reciprocating that. So, we just need to list the possible pairs that, of course, is relevant. So for us to check, we're going to use our formula. So we have here NCR is equal to R plus N minus 1 over R factorial N minus 1 factorial. So we have here our R, which is 2 plus 4 minus 1 factorial 2 factorial times 2 factorial. Teacher, asa gikan, 3 factorial. Teacher, asa gikan ng 3 factorial? From 4 minus 1, so n minus 1. So we have here 5 factorial over 2 factorial and 3 factorial. Siyang expand, so we have here 5, 4, 3, 2, 1 over 2 times 1 times 3 times 2 times 1. So, ato siyang i-cancel siya. Kaya same na. So, we are left with 5 times 4, which is 20. And 2 times 1 is 2. So, 20 divided by 2, 10. Is it the same from our listing or not? Okay, it is the same. Teacher, pwede naman na gidi ay ta mag-listing. Ano po ang kinahanglan ta mag-kuan sa formula? Then again, we need to consider that listing is very time-consuming and more on, it can be prone to errors. Well, if you know how to solve it using the formula, it would be pretty easy since you will no longer look back because you can just solve it and it's easier when, of course, when you're dealing with the bigger numbers. Now, if you're going to ask me, teacher, does the trick in the calculator can be applied to combinations with repetition? The answer is no. Because here in our calculator, it is programmed to just to solve the combinations without repetition. It is already programmed with NCR equals n factorial over r factorial times n minus r factorial. So in this case, if we try, let's just try. So we have here 4 combination of 2. The answer is 6, which was our answer on combinations without repetition. So let us move on to our example for you to further understand our discussion for today. So we have here, in how many ways can you choose 3 candies from 5 different types? If you can choose the same type more than once. So we have here our n. What is our n? So we have here 5. How about our r? Which is 3. So what is our formula again in combination with repetition? So we have here NCR is equal to r plus n minus 1 over r factorial n minus 1 factorial. So in this case, let's substitute its value. We have here 3 plus 5 minus 1 factorial over 3 factorial times 5 minus 1 factorial. So we have here 7 factorial over 3 factorial and 4 times 4 factorial. So let's expand. So I have here 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial, 2 times 1 times 4 times 3 times 2 times 1. Cancel out. We are left with 7 times 6 times 5. So 7 times 6 times 5. So what's an answer? 210. Divided by 6. So 210 divided by 6. What would be our answer? Okay, so we have 35. If we were to choose can three candies from five different types, and we can get more than once. So we can have 35 types or 35 combinations of candies. Clarifications or questions regarding this? None. So since you don't have any questions, I would let you answer problem number 2 or example number 2. A bakery offers types of donuts. How many ways can a customer buy a dozen donuts? Assuming unlimited supply. So, what would be our N here? 12. What would be our R? It would be 6. So, N12 R6. So, I will let you answer it on your chair. You only have 30 seconds left. Okay, you need to finalize your work. Okay, I'll give you 30 seconds more. Do you have your answers now? Who has finished? Okay, for a while. After I solve this, let's try and check if we really do have if we have the same answer. Wait for a while. So are you ready? Okay, so 3, 2, 1. Answer is okay, very good. The answer is 12,376 times. So, do you guys have any questions, clarifications towards combinations with repetitions? None so far? Are you sure? Okay, none. Okay, so now let's have a review on what we have discussed today. So, what did we discuss today? Yes, combinations. So, combinations, order does not matter. So, what are the types of combinations? We have the combinations with repetitions and combinations without repetition. So, what was the formula of combinations without repetition? Correct. How about the formula for combinations with repetition. Correct. Very good. You really did understand our lesson for today. And again, what's the difference between permutation and combination? Okay, permutation, the order does matter, and in combination, the order does not matter. So, I know you guys had already mastered the difference in permutation and combination. Now we will have an activity. Woohoo! So, I will group you into two groups. So, the right side would be the group 1 and the left side would be group 2. This activity is simple. I will flash some problems and I will give you 10 seconds to identify whether it's permutation or combination. Are you ready? So you are groups, you need to work together in order for you to answer it. So I have given you some band papers that you would write your answer. When I say time's up, you need to raise your answers. Okay? Are we all clear? Do you guys have any questions so far? None. Okay. So, are you ready? Okay. You are ready. So, we have here first problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Answers up. Very good. All of you guys had the correct answer, which is permutation, since we are asked to arrange. Okay. So let us move on to the second one. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Time's up. Raise your answers. So, the answer is combination. Why do you think it's combination? Because it asks for group or committee. Correct. So it's combination. It is because it did not emphasize that it needs to be arranged. It just need to be chosen. And from our discussion earlier, from differentiating permutation and combination, we have seen the examples of picking a committee. So that is combination. Very good. So both groups had the correct answer. So let's move on to the next one. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Answers up. What is this one? Are you sure it's combination? Why? Yes, still picking a committee, and it did not emphasize that it needs to be arranged. So, the answer for this one is combination. Very good, you guys. And the last one. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Answers up. Permutation. Why? Because it's a 4-digit pin. And as we all know, even if we had the right numbers, and if it's not in the right order, then our pin won't go through. So the arrangement does matter. Therefore, it is permutation. Please give yourselves a round of applause. I can really see that you have really mastered the difference between combination and permutation in word problems. So, let's have another activity called problem builders. You craft, solve, and share. So we have here same group. So your group will create two real world word problems. One involves combination and permutation. Each problem must include one realistic, relatable scenario, example, school sports events, a clear question, and a complete and correct solution with steps shown. So guys have 8 minutes to write, to brainstorm, and to make your solution. And I will check if you guys are copying from the internet. So I want original, okay? After the times is up, two representatives from your groups will present both problems to the class. Since your group is large and you need to make two different scenarios, so I am suggesting you guys to divide the task equally. So because you already have 8 minutes, okay? Are you guys okay with that? Do you guys have any questions in making this activity? None so far. Okay. So, time's up. Thank you. Group 1, please. Who are the representatives in Group 1? Okay, Miss and Mr. Please, all the groups, please paste your work in front. And the representative of Group 1, please come here in front to explain your work. Okay. Okay, let's give a round of applause for Group 1 for a job well done. Now, let's move on to Group 2. Okay, Group 2, please present your work in front. Okay, very good, Group 2. Let's give a round of applause for Group 2. Thank you very much, guys. I really did appreciate the things or the work that you have done, most especially from our activity. And I have really understood that you have really understand. Now, it is exam time. So, please get 1/2 sheet of crosswise. 1/2 crosswise, ma'am. Yes, 1/2 crosswise. Answer the problems for 5 minutes. Okay, time's up. Please give your papers or pass your papers to the front. Okay, give it to me. Thank you very much, you guys, for your cooperation and for the answers. And for the last time, we have our assignment to be answered in your activity or assignment notebook. Okay, I will collect this tomorrow and make sure to write the problem. It's copy and answer. To write the problem and your step-by-step solution. Okay? Do you guys have any clarifications or questions regarding our assignment for today? None so far. So that concludes our class. Thank you guys for listening and see you all tomorrow. Goodbye.